Using programmable or procedural SQL, we can also create our own stored functions. Stored procedures and functions are very similar. A stored function is basically a named group of procedural and SQL statements that returns a value, as indicated by a return statement in its program code. Stored functions can be invoked only from within stored procedures or triggers, and cannot be invoked from SQL statements unless the function follows some very specific compliance rules. Remember not to confuse built-in SQL functions, such as min, max, and average, with stored functions. To create a function, we use the following syntax. We start with the keyword create function, followed by the name of our function, inside the parentheses our arguments, and then the return keyword, and then the data type of our return. In between our begin and end are our PL/SQL statements. Since this is a function, make sure that we have a return statement inside, and then the value or expression that we're going to return. In the real world, database systems are related to other systems and programs, and you still need a conventional programming language such as Visual Basic.NET, C#, or COBOL to integrate database systems with other programs and systems. If you are developing web applications, you are most likely familiar with Visual Studio.NET, Java, ASP, or Cold Fusion. Yet, almost regardless of programming tools that you use, if your web application or window-based GUI system requires access to a database such as MS Access, SQL Server, Oracle, or DB2, you will likely need to use SQL to manipulate the data in the database. Embedded SQL is a term used to refer to SQL statements contained within an application programming language, such as Visual Basic.NET, C#, COBOL, or Java. The program being developed might be a standard binary executable in Windows or Linux, or it might be a web application designed to run over the internet. No matter what language you use, if it contains embedded SQL statements, it is called the host language. Embedded SQL is still the most common approach to maintaining procedural capabilities in DBMS-based applications. However, mixing SQL with procedural languages requires that you understand some key differences between the two. First is runtime mismatch. Remember that SQL is a non-procedural, interpreted language. That is, each instruction is parsed, its syntax is checked, and it is executed one instruction at a time. All of the processing takes place at the server side. Meanwhile, the host language is generally a binary executable program, or otherwise known as a compiled program. The host program typically runs at the client side in its own memory space, which is different from the DBMS environment. Second is processing mismatch. Conventional programming languages process one data element at a time. Although you can use arrays to hold data, you can still process the array elements one row at a time. This is especially true for file manipulation, where the host language typically manipulates data one record at a time. However, newer programming environments such as Visual Studio.NET have adopted several object-oriented extensions that help the programmer manipulate datasets in a cohesive manner. And last is data type mismatch. SQL provides several data types, but some of them might not match data types used in different host languages. For example, the date and varchar2 data types. To bridge the differences we have just discussed, the Embedded SQL standard defines a framework to integrate SQL within several programming languages. The Embedded SQL framework defines the following. First, a standard syntax to identify embedded SQL code within the host language. Second, a standard syntax to identify host variables, which are variables in the host language that receive data from the database. And last, a communication area used to exchange status and error information between SQL and host language. This communication area contains two variables, SQL code and SQL state. The following table shows some of the main values returned by the variables and their meaning. We have a static SQL if a programmer uses predefined SQL statements and parameters. That is, the SQL statements will not change while the application is running. Unfortunately, end users seldom work in a static environment. They are more likely to require the flexibility of defining their data access requirements on the fly. Therefore, the end user requires that SQL be as dynamic as the data access requirements. Dynamic SQL is a term used to describe an environment in which the SQL statement is not known in advance. Instead, the SQL statement is generated at runtime. At runtime in a dynamic SQL environment, a program can generate the SQL statements that are required to respond to ad hoc queries. In such an environment, neither the programmer nor the end user is likely to know precisely what kind of queries will be generated or how they will be structured. Although dynamic SQL is clearly flexible, such flexibility carries a price. Dynamic SQL tends to be much slower than static SQL. Dynamic SQL also requires more computer resources. And finally, you are more likely to find inconsistent levels of support and incompatibilities among DBMS vendors.
To summarize, we have learned the following. We have introduced views and how to use them. We have also introduced PL/SQL blocks, including triggers, stored procedures, and functions. We have talked about embedded SQL and learned about anonymous PL/SQL blocks. And finally, we have done some PL/SQL processing using cursors.